Welcome back to the last video of this unit. This last part here is percent yield. This is a part that we skipped over in the packet, which is section number part 5. Part 5 here. Okay? We have already done some mole conversions. Mole mass, grams to grams. And we did limiting reagent and excess last class. So make sure you know how to do all that before you continue on to this thing. Even though this part is easier than the other parts, it's actually easier than the limiting excess. But you have to know how to do grams in order to do this limiting. To do this percent yield. Okay, so percent yield, as you can see, it's going to be some kind of percentage, and percent yield, what it is how much you recover compared to how much you expect to get. Okay, so it's how much you actually get from a reaction. Because, for example, if we make, let's say, if we have enough ingredients to make 10 s'mores, okay, so we expect 10 s'mores, correct? And somehow, some way, we only made 8. Because what happens to some ingredients? Maybe we dropped something. Maybe somebody ate some of the ingredients along the way. It happens. So then the percent yield is how much actually we get over what we expect. So it's 8 divided by 10 times 100. Okay? And the equation is actually some fancy science word. It's called actual yield over theoretical yield times 100. Okay, that'll be percent yield. Percent yield. Yield is how much you actually make. Okay, the yield. This yield is different than the yield in driving. You drive, you make sure you give the right of way to other people. But this yield is how much is produced. Just like in our equation, yield is an arrow. In other words, it's kind of like equal. This plus this will make that. Okay, this yield. All right. So actual yield over theoretical yield times 100. Some hints here. Okay. Actual yield is most of the time it's going to be given to you. All right. And it's going to be given, and you can identify it with a couple of keywords. Things like produced. They'll say actual, maybe actually produced, or obtained. What else? Produced, obtained, recovered, etc. There might be a couple other words that'll show up later that I can't think of right now. But those are 3 words that might give you a hint that it is the actual yield. And actual yield goes on top. It's what you actually get when you run do the experiment. For example, hydrogen plus oxygen gives you water. Right? It's not always perfect. Because if it's perfect, it gives you 100%. So when it's perfect, that's a theoretical yield. This is how much you're supposed to get. This is the expected amount. And where do you get this? You get this from doing the grams, mole, grams. What we've always done. What we've done in the past couple of classes. When we do grams, mole, grams, we say that ideally it's perfectly. When if it's perfect, that's how much is going to be produced. 100%. That's a theoretical yield. If everything works out perfect, you need to do the grams, mole, grams to get the theoretical yield. Actual is given to you, divide it, and you get your percent yield. Okay? Let's go through this packet, things that matter to us, that you'll turn in after we finish this. So here, in a real laboratory setting, things are not, or things do not, always work out perfectly. In a stoichiometry problem, you can determine the theoretical yield that would result from a reaction if it works out ideally. The actual yield is the amount that is really obtained. The actual yield can be higher or lower than the theoretical yield, depending on things like contamination or loss of material during the steps. Okay, contamination may allow you to make more product than you expect because you add some other stuff in there. Because this is all in grams. So what if you made 10 s'mores, but it weighs different because you got some gunk on your hand that's stuck to it? Yeah, disgusting. Okay, the percent of the actual yield divided by the theoretical yield, then multiplied by 100. All right. So here's a sample problem here, and I'll do one more with you. Okay. Let's do number 37. Okay. You will complete 36 to 40. Should you do that? Okay, 36 to 40. But I'll do 37 with you. Over the course of 5 minutes, 20 grams of that was consumed. Okay, that's consumed. That's used up. That's not produced. So that's not your actual. Assume that hydrogen gas is a limiting reactant. So you're going to start with 20 grams of hydrogen gas. If 110 grams of ammonia is collected, in other words, collected. It's a key word to give you. This is your actual. Okay, so you leave that alone. You're not going to use that yet. So this is ammonia, actual for ammonia. So you need to find the theoretical for ammonia. So the theoretical here, okay, is 20 grams of H2O. We use our grid to go to grams of NH3. Mole of H2. Mole of NH3. Okay, grams of H2 down here. Mole of H2 down here. Mole of NH3 down here. By now we should be very familiar. 1 mole of H2 is 2 grams of H2. Mole to mole, go back to the equation up here. 3 NH2, 3 H2. Oh, 2 NH3. My bad. Okay, and 1 mole of NH3 is 17 grams of NH3. Do all that. Handy dandy calculator. 20 times 2 times 17 divide by 2 divide by 3. And I get 113.3 grams of NH3. This is my theoretical. Okay? So the equation is percent yield is equal to actual over theoretical times 100. Alright? We'll plug that in. Actual, it's given in the problem here, 110 grams. Theoretical, 113 grams times 100, and you'll get your percent yield. 110 divided by 113.3 equals times 100, 97.1%. And that's how you find percent yield. Okay. So the only new thing, ladies and gentlemen, that we've done so far for this part is finding the actual. Okay. We found theoretical all the times that basically everything before this page we found theoretical values. That's theoretically, if it works perfectly, that's what you get. But this time we added an actual, and then all we added was this part right here. It's simple formula. Percent yield is equal to actual over theoretical times 100. Okay, so why do we need to know this, or why is this important in chemistry? This is important in chemistry because when it's never a perfect reaction. There's no such thing as a perfect reaction. There's going to be some losses. Okay, so people aim for the best methods, the best way to get the highest percent yield possible, so they don't waste the materials. So companies evaluate themselves, or they profit more if they get higher yields on whatever reaction that they make. Okay, so just like if you were baking cupcakes, right? So if you can make 20 to sell, you would want to make 20, right? Or 19 or 18, maybe like that. But you don't want to end up making only 4, then you lose money like that. You're not making money. So percent yield, most things we do, we want a higher percent yield. Okay, so in chemistry, the same thing. Any kind of chemical reactions, we want the most product possible. So the higher percent yield, the better. It's like on your test, percent yield. 20 question test, and you resulted in what, 10 questions right? Percent yield is 50. Same thing. Same thing. Okay? Kind of like part over whole times 100. Actual over what's expected, which is theoretical, times 100. That's your percent yield. And that's it for this unit. Good job, ladies and gentlemen. Goodbye.